welcome back to my channel. Hope you are doing extremely well, and this is a very on mass code is this side. So welcome to lecture number 16 of the binary tree series, and we are going to solve the problem of constructing a binary tree from post order and pre-order. Earlier in the series we constructed a binary tree from pre-order and in order, followed by post order and in order, and now it is time for us to do the post order with pre-order. This is the last of this type of problem, right? So we were able to construct a pre and n, a unique binary tree. From these two traversals, we were able to construct a unique binary tree. From post and in order also, we were able to construct a unique binary tree. But to a surprise, from the post order and pre-order, we cannot construct a unique binary tree. We cannot construct a unique binary tree. Let us see how. So for example, the post order traversal is given to me as 3, 2, 1, and the pre-order traversal is given to me as 1, 2, 3. Now I can make three cases of this type of problem, three types of trees which will give me the same pre-order and post-order which I require. For example, 1 connected to 2 connected to 3. If you see the pre-order traversal, by the technique I show you, 1, 2, 3, if I traverse this, you can see the pre-order traversal is 1 to 3 only, and the post-order traversal is 3 to 1, right? Okay. Constructing the another tree, 1 connected to 2 on the left, but 3 is connected on the right. Now if you see the pre-order traversal, it is again 1, 2, 3, and the post-order is again 3, 2, 1. Now you can see there are two types of trees which are actually giving the same traversals, right? So you can see there are two types of trees which are actually giving the same traversals, post-order and pre-order, and that is why I cannot construct a unique binary tree. Unique binary tree is not possible when I have been given the traversals of post order and pre-order. But in these two cases, you can always make a unique binary tree. Okay, so we have discovered something that we cannot make a unique binary tree. That is why the problem statement also says that we have to make one binary tree which is obeying our instructions. That is, the post order and pre-order should be same for that binary tree, and then you are free to go, free to move on, right? Now if you see for this tree, the post order is this one, the pre-order is this one. You can match it. I have already taught the traversals to you, right? Now the main problem is from these two traversals I have to get to this tree. How will I do that? How will I do that? So as I said in the previous definitions also, that I have to go through the definitions. I have to go through the definitions. So what is the post order traversal? Post order traversal says that explore the left subtree first, come to the right subtree then, and then go to the root. And similarly, the pre-order traversal says that go explore the root first, go to the left subtree now, and then the right subtree, and then the right subtree. Let me rub this down. I hope that is clear to you that we cannot make a unique BST. Now, if I try to focus on both of these, if I try to find the root in the post order, it is at the last. In the pre-order, it is at the first, right? So if I try to see that post order contains 4 in the starting and 1 in the end, and pre-order contains 1 in the end and 7 in the starting, you can see that these two elements are matching. One is matching with one. Why? Because pre-order start with root and post order end with root. So I'm sure about one thing, that 1 is gonna be my root node. This is for sure. This is for sure. Now the problem arises is that I don't know where to get my left subtree and where to get my right subtree, right? So for the given example of post order, this whole 4, 5, 2, 6, 7, 3 consists of both. Like it is a merge of left, right, and left and right subtree, right? But I don't know which part is in the left and which part is in the right. I don't know about the distinction. If I go to the pre-order for help, the pre-order does not have that also, right? Root is on the left part. I don't know about where the distinction of left and right comes. Can I use these both left right to get a distinction? To get a distinction. For example, if I pick up 2, let me rub these lines. If I pick up 2 and try to find 2 in the post order, so 2 is occurring here. Let us say that I want to assign 2 to the left pre-order. I want to assign 2 to the left of subtree, right? If I'm assigning 2 to the left subtree, that means this 2 is also on the left subtree. And if this 2 is on the left subtree, that means 5 and 4 have to be on the left subtree. Try to think, if this 2 is on the left subtree and I'm occurring with the left on the first part of the post order, like the post order is divided into left part, the right part, the root part. If 2 I'm assigning to the right part, then 4 and 5 have to be on the right part. So if 2 is on the right part, then 4 also on the right part and 5 also on the right part. And if I want to assign 2, let us say that all these 3 elements are going to be on the right. That is 6 is going to be on the right, 7 is going to be on the right, and 3 is going to be on the right. You can see the 2, 4, 5 are occurring as a group, and 3, 6, 7 are occurring as a group. Now among 4, 5, 2, again the distinction. So 452 is here and 245 is here. You can again see that 2 is at last here, 2 is at first here. So again 2 is gonna be my root, right? And similarly for 673, you can see 673 is here, 367 is here, and you can see 3 is at first here and 3 is at last here. So 3 is gonna be my root here. Now again the same cheese. So 4 is ahead in the post-order traversal. So 4 is here, 4 is here. That means 4 is gonna be on the left subtree. 4 is gonna come here. And what about the right subtree? So when I see 4, I see 5 is there. So 5 is gonna come on the right subtree. 4, 3, you can see 3 is here. If I try to find 6, 6 is gonna come at here and 7 is gonna come at here. Now when only one nodes are left, you can just make the nodes. So 4 will come here, 5 will come here, 6 will come here, 7 will come here, and this is my tree. You can match it. This is coming to be the same. 1, 2, 3, 4, 5, 6, 7. Now I want to tell you that how to do that. We have to see, like we developed an algorithm. Whenever you are solving a DSA problem, you have to go through the algorithm. That part is done. And now if you are a good DSA, like DSA writer or the code writer, algorithm is not hard to convert into code, right? Code is the easiest part according to me. If you know the algorithm, code is the easiest part for you, right? But we have to break down the code. So if you see, for the given code, for the given arrays, what did we do? We explored the whole ranges. For to get the one, we got this starting and this ending. So what did we do? The process for one, the process we applied on the one, the code we applied on the one is exactly similar to the process we applied on the two, the process we applied on three, the process we applied on 4, and 5 and 6 and 7, comma 5, comma 6, comma 7. So you can see the process is the same, but the size of the arrays are different. For the process 1, the size is this much. For the process 2, the size reduces to this one. For process 3, the size reduces to this one, 673, right? So it is actually a case of divide and conquer. That means recursion is happening. Divide and conquer. Recursion is taking place. And whenever recursion is taking place, the code is going to be short. Now how to do that? How to get the answer? So let me write down the pre-order and post-order again downside. Here are the pre-order and the post-order traversal. Similar to the previous problems of constructing the binary tree, I will require 4 pointers for pre-start, pre-end, post-start, and post-end. Right. Now the first step you have to make a root. So my root is gonna be a new node. What is the value I'm gonna fill? I'm gonna fill the 1 value. So that will be pre-start. Right. My next step is to find the index of second value. Index is equals to -1. The value I'm looking for is pre-order of pre-start plus 1. Let me mention pre-start as pre-s plus 1. Okay. I want to find the value. So for I going from post-start up till post-end -1. Why -1? Because 1 is already been used. So post-end -1. What will you do? You will say if post of I is equals to value I require, that means I have found the index. The index is going to be I, and I can break out of the loop. Right? This is the if condition I'm looking at. Right? Now, as soon as I find end, this is my index, right? This is my index. Now I know these two elements are on my left subtree. These 3 elements are on my left subtree, and these elements 6, 7, 3 are on my right subtree. I want the number of elements on the left and right. So left and right. Can I compute left and right? Yes. This is my post start. This is my index. You can see 0, 1, 2. Index is equals to 2, and I'm getting the answer as index minus post start plus 1 in the left, right? So it will be index minus post start plus 1. And what about right? So it is post end -1 and it is index plus 1. So post end -1 minus index, like index plus 1, right? Plus 1. Why plus 1? Because 6, 7, 3. You can see that I have to increment 1 to get the 3 values. So 1, 1, and it will be post end minus index -1. Post end minus index -1. That will be equals to post end minus index -1. Right? So I got the left elements, I got the right elements. I just want to define the ranges now, as I did in the previous 2 problems, right? After getting the number of children in left subtree and the number of children in right subtree, I want to get the ranges. So root left is going to be the same function for both the traversals. Now what is the pre-start? So I've already used this value. My pre-start is starting from the original pre-start plus 1. So pre-start plus 1, and my pre-ending is going up till the left. So I want 3 children, 1, 2 and 3. So I want to go to pre-start plus 1, pre-start plus 2, pre-start plus 3. So it is going to be pre-start plus left, right? Because my left is containing 3. Now what about right? What about right? So right, like what about post start? So post start is starting from 4 and going up till index. So it is starting from post start and going up till index. This is done. Only the root right is done. So root right is gonna be f of the two traversals, and the pre-start is now gonna be, you can see that I want 3 children. I want right number of children. So my pre-end pre-end is gonna be the same. So I want right children. That means this is n minus 1, n minus 2, and minus 3. So I want pre-end minus right, pre-end minus right, and it will go up till pre-end. What about post start? So for the right subtree, post start is starting from index plus 1 and going up till post end minus 1. So it is starting from index plus 1 and going up till post end minus 1, right? This is going to be my root left, then root right, and you can simply return root at last. Return root at last. Now, if any one of you want the dry run, so dry run is actually this only, which we made this tree. The dry run was that only. This is the same code, same dry run. Okay. What did we do? We just found the element as the root. We found the index of this element. This is going to be my left subtree. This is going to be my right subtree, and we just played with some mathematical values. That's all. These are just some observations. This is not intuition. These are just some observation, right? So let us now move to the code. Hope you are excited. See the coding section in front of you guys, but before starting with the code, I would like to request you to please subscribe my channel, because it really motivates me, right? So let us start coding it. So int 10 is gonna be preorder dot size, and now what you have to do, you just have to say return the f function which you are going to implement soon, send the preorder, send the post order, send the pre-start as 0 and pre-end as n minus 1. Similarly, post start is going to be 0 and post end is going to be n minus 1, right? Let us implement the f function. So f function is running a tree node. So tree node star f is going to be vector of int and pre-order, vector of int and post order. Now int pre-start, int pre-end, int post start, int post end. Now, what you have to do, if your pre-start actually exceeds your pre-end, that is your base condition, right? You have to return null. You have to return null. Otherwise, if both the values are equal, that means you only can make a node out of it, only the root node and nothing else. So if they are equal, just return new tree node with the value of pre-order and send the pre-start in it, PS, right? Now, otherwise, what you have to do, just construct a new node, tree node star root is gonna be the same. So I'm just copying it down, right? Now, the value we need to find is pre-order of pre-start plus 1. Index is gonna be minus 1 currently. We are going to find the index. So for int I going from post start I less than equals to post end minus 1 I plus plus. If the value becomes equal, that is if post order of I is equals to well, that means you have found the index equals to I, and then break. Now what will you do? Now you have the index. Now our int left is gonna be, as you can see on the right side of the window, it is gonna be index minus post start plus 1. Similarly, int right is gonna be post end minus index minus 1 as discussed, and root left is now gonna be f of, similarly, pre-order, the same function, traversals, post order, and now it will be pre-start plus 1 up till pre-start plus left, and post start is going to be the same up till index. And similarly, root right is going to be f of pre-order, send the post order, and send pre-end minus right minus 1 as discussed, and pre-end as usual. And similarly, the post start is going to be index plus 1 and post end is going to be post end minus 1. At last, return the root when the recursion call finishes. Let us try to compile and run it. Hope it will work fine. and it is running. Okay, it is getting submitted for the sample test cases. Let's hope it works for the hidden test cases as well. And it is getting accepted. So thank you for watching. Hope you liked it, and make sure to subscribe to the channel and like the video for more such amazing content. Thank you. Have a nice day.